In this video, we're going to focus on the solution for Review Activity 9-4, where it asks us to determine the minimum number of size and location dimensions required to completely dimension the given views. So we're given the front, the right, and the top view, and I added the isometric. I did this in CAD software, and I just did it by looking at it. I didn't necessarily measure it, so the dimensions could be off if you're using a ruler against what's in the book. But we're not asked to measure it, we're just asked to compute the minimum number of dimensions. So let's imagine for a moment that you had to build this part. You would have to start with what was called a blank or a piece of stock, and you would need to know how big that blank or that piece of stock needed to be. And you would need to know the depth, the height, and the width of this part. So let's start by putting in those dimensions. So I will put that one there, put the height in, and I could put the depth here, or I could put the depth between here and here. Let's put it in the top view on the right. I think that makes the most sense. So now I know that I need to find a piece of metal or wood or whatever I'm going to build this out of that is at least minimally these dimensions right here. Now the next thing I need to do is I need to locate the center of holes and hole features. This has one hole right there. So I need to know where the center is. So what I'll do is I'll measure from this edge to the center. So that's one dimension. And then I need to measure from this edge to the center. And that's that dimension. I also need to know the diameter of the hole. Okay. So now, what else do I need to know? This part has a couple more features. It has two tabs coming out, and one of the tabs has a chamfer right here. So I've got to do something to give the person that's going to build this information on how to build that. So I say that it's better to measure what you can grab. And these two tabs here I could grab very easily with a caliper or a micrometer. So I'll dimension those. 1, 2, okay. And I need to know this depth right here. What's the depth between this face and this face? I'll put that dimension in right here. Okay. And then I need to know something about this chamfer. So what I can do is I can dimension between here and here, and that gives me that edge right there. Now, can I put a dimension between here and here? The answer is no, because 0.62, 0.38 add up to 1, and that's called double dimensioning. There can only be one way to determine a part's length, size, location, etc. So if you can determine it with two different sets of dimensions, there's a problem. So if I want to know the length of this edge, I have to subtract 0.62 from 1. I have to do the math. I cannot double dimension it. But what I could do here is I could put an angular dimension on this chamfer angle right there. And I think that's going to do it. So, do you have all the information that you need or would need to build this part? I think the answer is yes. We know the height, the depth, the width. We know the location of the center of the hole. We know the diameter of the hole. We know the width of all the features, the depth between this edge and this edge, or between this face and this face. And we know the angle of the chamfer. Also, did we dimension to any hidden lines? No, we did not. You'll notice that we dimensioned the round feature and the round view. We didn't put any dimensions between the hidden lines or the center lines. That's one of the dimensioning no-nos. So I think that's going to do it. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 dimensions. I think that's the minimum amount to build this part. In the next video, we'll look at the next part.